And I'm live. That is cool. Today is 12th of December 2025, Friday, and yeah, let's just start solving the problem for the day. Advent of code. And before solving the problem, we have to see which language we end up on today. And this thing does not work. Dark and white mode. Okay, and there are just two languages remaining, so I guess we will do three spins as always, and there are just two languages remaining, C++ or Swift as written, and let's see how it goes. The language on which the spinner lands on the third spin will be the language for today, and let's see. Spin, and I would prefer to get Swift today. First spin, we do get Swift. Spin number two, and let's see. We get C++, and now spin number three, the final spin, the language in which we will do today's problem is C++. So that is cool. Well, shit, that is actually cool because today is day 12 and I am getting C++ on day 12, and day 12 is supposed to be the hardest, so getting the language that I'm most comfortable with on the most difficult day is cool. Is cool. Let me update the thing here. It is supposed to be here. Yep, day 12, and well, we do know now C++. Let's go. Shit, that is actually crazy. That is actually crazy. Yep, just 1 minute, let me fix this. About chat and cool. So C++ is for today, and hello there, Kause. Iron code, CD, day 12, touch text.txt and whatever. And yep, I didn't do day 11 because I was not like here and stuff. And day 11, I guess I will either do a stream for day 11 or I'll do it myself. You are almost out of time, but there cannot be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire holes, or conduits here that would take you deeper into the North Pole base. There is a ventilation duct you jump in, okay? After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. Okay, there are a few elves there frantically decorating before the deadline. They think they will be able to finish most of the week, but the one thing they are worried about is the presents for all the young elves that live here at the North Pole. It is an ancient tradition to put the presentations under the trees, but the elves are worried they won't fit. Okay, they want to put the presentations under the tree, but they are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured in standard units. Okay, to be aesthetically pleasing, the presents need to be placed into the regions in which way that follows a standardized two-dimensional unit grid. You also cannot stack presents. Okay, the presents should be in a two-dimensional grid. As always, the elves have a summary of the situation your puzzle input for you. First, it contains a list of the presents shape. Second, okay, shape. Second, it contains the size of the region under each tree and a list of the number of presents each shape that need to fit into that region. For example, this. Okay, wait. As always, they have a summary. First, it contains a list of the presents shapes. Okay. Second, it contains the size of the region under each tree. Okay. Shapes of the presents and the size of regions under each tree, so there are multiple trees, and a list of the number of presents of each shape that need to fit into that region. Okay, and the region under each tree. Okay, if this has been given to us, what does this mean? This means that the first section lists the standard present shapes. Okay, this part, these are shapes that a gift is going to take. For convenience, each shape starts with its index and a colon. Index and a colon, and then the shape. Okay, there is a present in C shape and this shape and this. Okay, these are the shapes. Then the shape is displayed visually, starting where this is part of the shape and dot is not. Okay, the second section lists the regions under the trees. So there is a 4 by 4 tree which needs to fit these things. There is a 12 by 5 tree which is going to fit these shapes. Okay, that is crazy. That is actually crazy. The shape is displayed visually. The second part, regions under the trees. Each line starts with the width and length of the region. 12 by 5 means the region is 12 units wide and 5 units long. The region of the line describes the presents that need to fit into that region the quality of by listing the quantity of each shape of present. This means you need to fit one present with the shape index 0, one present with the shape index 0, 0 presents of shape index 1, and 1 present of shape index 2, and 3 presents of shape index 4, and 1 2 3 4, yep, and 5, 2 presents of shape index 5. Okay, presents can be rotated and flipped as necessary to make them fit into the available space, but they have to always be placed perfectly on the grid. Shapes cannot overlap, that is this hash part from two different presents cannot go in the same place on the grid, but they can fit together, that is the dot part in the shapes and diagram does not block another present from occupying that space on the grid. The elves need to know how many of the regions can fit the presented list. In the above example, there are 6 unique present shapes and the 3 regions that need checking. The first region is a 4 by 4 region. In it, you need to determine whether you can fit 2 presents that have the index 4. Can we fit 2 presents which have index this? And no, we cannot. Wait, we actually can. We can. Yep. In it, yep, this is shape number 4, and yep, here we can actually, yep, here we can actually fit 2 of these shapes, and this and this would be the two places, coordinate points that will be empty. After some experimentation, it turns out that you can fit both presents in this region. Here is one way to do it, using A to represent one present and B to represent another. Yep, yes, this same thing. The region is 12 units wide and 5 units long. In that region, you need to try to fit one present with shape index 0, one with shape index 2, two presents with shape index 4, and two presents with shape index 5. It turns out you can uh, it turns out that these presents can all fit into this region. Here is one way to do it, again using capital letters to represent different shapes. Okay, the third region is the same size as before. The only difference is that this region needs to fit one additional present with the shape 4. Unfortunately, no matter how hard you try, there is no way to fit all of the presents into this region. So in the example, two regions can fit all of their listed presents. Consider the regions beneath each tree and presents that elves would like to fit into each of them. How many of the regions can fit all of the given prices? Okay, that is crazy. Any resources for learning graph? I guess you can. Yeah, graphs are cool. Graphs are simple and cool, and I would say you can go to CPHP Competitive Programmer's Handbook, and this is not comprehensive, but you can use this as a stepping stone or as a index. And like, yeah, you might need further reading to understand the topics which are explained here, because they have like 1 or 2 page explanation for what is Bellman-Ford algorithm and other stuff. But if you do not understand from the context that is given in this book, you might need other resources, but you do not need to. Generally, you wouldn't be required to learn or like get into more things than what are explained here, and that is cool, right? This you can use as an index. This has some cool stuff. Graph representation, you can represent a graph as adjacency list or as a list of edges or as adjacency matrix, edge list. Yeah, cool stuff in CPHP. And this is the question for today. Okay, how would you even approach a question like this? That is crazy. And these are the only shapes that we have. Okay, 5, this one, 4, and we can flip and do whatever we want with these shapes. There are a lot of trees. Yep, there are a lot of trees. And okay, how would you even approach something like this? This is crazy. This is crazy. We can flip these things in whatever way we want to flip them. That is nice. Can this shape this many times, 33 times, along with these other shapes, these many times, fit into a 2 by 2 grid of size 39 into 38? That is the question. How would we even begin? Like, what would be the way to represent data? A list would be nice. A list of length 3, where we could have 1 wherever there is like a hash, and 0 wherever there is a dot. Yes, a list of size 9, right, which basically is just reducing this two-dimensional thing into a one-dimension thing. Okay, before moving to like more complex shapes, like all of these shapes this many times, I think we should think more about how would we approach solving this 4 by 4 problem, which is more simpler, makes sense. So we have a 4 by 4 grid, let's say. 4 by 4, yep. And the answer, and we want to fit this shape into this grid twice, which we can do by putting these two shapes like this. Yep. Now that is cool. But how did we reach this conclusion? We can just like look at this and see how it is, but what algorithm, or like what are what do we have to look for in this? A shape can be rotated. There are 4 different positions for a shape to be like, if we have a arrow, if and then we can have it in like this position, this this or this. There are like four different rotations for it, because here these shapes are a combination of a 3 by 3 grid, and yeah, there would not be any rotation at like the rotations are only 0 degree rotation, 90-degree rotation, 180-degree rotation, or 270-degree rotation, and there are no in between rotations. Yeah, you won't get a shape like this because it will not, I guess, fit in this. Or maybe even if it could fit, it would make more sense to rotate these shapes in these four at these four angles, because then I think we will be getting most of the area out of this 2D grid. Okay, these are the four different rotations, but can we flip the shapes, or would flipping even make sense? I don't think flipping would make sense. Like, that flipping would change anything. Rotated and flipped. Yeah, so we can rotate and flip, does not matter. So these four things, and then the flipped versions of all of these four things, which does not like is not visible here, but flipness would be visible in something like this, in a shape like this. So there are 8 different positions a shape can be in. Okay, this is crazy. How would we begin solving a thing like this? This thing can fit in this. That is cool. This thing can directly fit in this. How do we introduce the concept of fitting? And it would depend on how we are representing data, and storing this as a 3 by 3 grid, storing the shapes as 3 by 3 grids. Does it make sense? If I have a shape which is 3 by 3 like this, storing it as a like Cartesian 3 by 3 grid, does it make sense? Or storing it as a singular array where we would have x, 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 then like space, then x, then x, then space, and then x, which is just row by row representation, row number 1, row number 2, and row number 3. And we know that the shape can fit in here like this. And if we were to flip, or yes, if we were to represent this blue shape in this single row representation, it would look like this. Like this, and x, x, and then x. And now what? I don't share. This thing does not make sense, I think, because yep, this thing does not make sense because the space in which we want to flip them requires 4 by 4 two-dimensional grid, but this linear representation is of a 3 by 3 2D grid. So yeah, these don't match. And also, like, if we are going to store these patterns as one-dimensional grid, there is a like implicit or explicit understanding that each row is of three cells, but the area where we are going to store all of this, that is definitely going to be more than three. So yeah, I don't think this makes sense. And this would, I think, actually require more calculation of translating between something like this, where in the row size is something else, and here where the row size is 3. Hello, your consist. Oh, thank you. And from code forces to advent of code, great journey. Yo, let's go. Let's go. And yeah, I'm actually not doing a lot. I'm like actually should be doing more than what I'm doing right now. Okay. And thinking. How can we represent data and how can we fit these together? Fit these shapes together. And yes, using ChatGPT is not an option. Shape can be this or this. Can we just start putting everything together and then at the end see where we landed? Let's say, can we think of this like this? Let's say we have some arbitrary shape and we have a small 3 by 3 shape which you want to add here, put here by increasing. Let's say there is an invisible boundary around this arbitrary shape of straight lines like this, kind of like this. And this new shape that we want to add into this, we want to add this in such a way that adding this shape does not lead to increasing the area of this invisible boundary. Like if there is an option of putting this new shape here, that would lead to moving this imaginary left boundary left by some amount and increasing the overall area. But if there is also an option to put this new shape around here somewhere, that does not lead to increasing this outer boundary in any way or form. So that is good. And we can, in this greedy manner, start putting these shapes. First, we'll start from like empty thing where we don't have anything, we just have our empty grid. We will put some shape in that grid and we'll keep adding shapes in a manner which does not increase the size, which increases the size in the minimum way. And then after we are done, we will like look at what the size is. If we can fit this whole thing into the tree or the region in under the tree, then we are good. Otherwise, we are not good. Yeah, I think that is something. But how would we prove that making this greedy position and greedy choice? First of all, how would we make a greedy choice? And second of all, would making a greedy choice, whatever in whatever manner it is possible, would that lead to a global optimal? Like, would that lead to the best possible solution ever possible? Hello. Yep. Final last day. C++. Today is C++. But the question is also like difficult. And this is the question. We, these are like, we have these visual shapes here, which we want to put into a 2 by 2 grid of size this. And these numbers, they just mean that like the shape number 0, which is this shape number 0, I want to put 42 of those shapes, 38 of shape number 1, 49 of shape number 2, and so on, 33 of shape number 5, which is this, into a region whose size is this. And all we have to figure out for each region, for all of these regions, is for how many regions can we successfully put all of these shapes into whatever the size of the region is. And that is something. There are, I would say, not a lot of reason. Back to basics. Yep. Basics. Yep. C++. The question is there a strategy required? When yes, I'm thinking of this, and like if I have already a shape present and I am putting a new little new 3 by 3 shape into an already present shape, do I need to know? Yes, I think I would need to know what the size of the region is. For example, if the region is longer in this manner, like longer where the height is small but the width is very large, then I would like to add this new block into my already present shape in a way that it only increases in one direction and not so much in the other direction. Yeah, so shit. Knowledge of this is also required. Backtracking. I think backtracking. Yes, I think backtracking, because this is like the queen question, the placing n queens on a n by n grid so that they do not attack each other. Right? If you have a 4 by 4 block like that, 4 by 4, and you need to put uh 4 queens in here. I think you can put them like that. Yep. These are all queens on a 4 by 4 chess block, and they are not attacking each other, and this requires, this you can solve by backtracking, and I think we can, yeah, it seems like we can apply backtracking here, but but thinking, we have also have to think of how many choices we have at each level, because if in the queen algorithm we have a n by n grid, then if we are moving row by row, then at each row we have n different possibilities and different positions where we could put the queen, right? And there are n rows, so the time complexity, you could say, and this is when we want to put queens on our n by n board, is n square of the backtracking, right? Because we are going row by row, and at each row there are n possibilities of cells where we could put the queen, and there are n rows in total. So what would be the time complexity of this? Let's parse the input. Hello, and do not call me sir, and hello. Quaternion 3 2 6 7, some random number at the end of your name is crazy. Okay, let's try to do this. part1 dot cpp. Finally, we can write. Delete that other one. Okay, and shared C++. Finally, and F L or shared. Okay, my caps lock is working as a caps lock, which is not the required like behavior that I want. What happened to OCaml? OCaml, I said after D12, and now finally, I like my next exam is on Monday, so that is cool. I also was, I had my exams. Yep. And just a second here. Keyboard shortcuts, modifier keys, make the caps lock the control key, and not on this keyboard but on the USB keyboard. Caps lock should act as the control, so that is cool. So tomorrow or from Tuesday? From tomorrow, OCaml from tomorrow, and I won't go into like the OCaml core stuff, but Windows cannot handle this shit without third-party application. Shit. Uh, at least that is something that I have. Cool. And because caps lock working as control is so good for them, I do not have to go to like escape. Escape is too far away with the pinky finger. I can just press on the caps lock, which is now acting as control, and open square bracket, which acts as escape in Vim. So that is cool. F extreme. How do we declare our F stream? I think it is F stream file and then dot slash text dot txt, and then let's say std string s equals file dot, wait, share. We also have to open. That is crazy. November function call to open. What does it take in some input? Uh, because doing code forces, I have never used reading and writing to files in C++. Yep, this is my same, this is my go-to thing. The habit of struggling, guitar is paying off now. Wait, okay, bro is also into guitaring. Extended fingers, shit, superpower. Extended fingers can be used somewhere else. So yeah, same. But escape isn't too far. For my, it is. It feels like I have to move my whole hand to get there. Yep, fingers are too big. How to read a file in C++. Input file stream. Yep, open input file stream. Create a string. Shit, it just acts as a stream. Yes, I am stupid. Wait, input file stream, and while is or not console.log. Using namespace std. include IO stream, compile and run, and yo, we do get the whole thing. That is cool. So now we have to parts, then put, and yes, this is now Harpoon. Harpoon, yes. The plugin by Primeagent. Harpoon. Yeah. Harpoon is working right now. Look at this. This thing is being done by Harpoon. These are the two files in the Harpoon menu or whatever, and I can switch between them very, very fast. What do you think? Why will love guys? I don't know. Have no idea. Try doing a C style file reading. Instead, you have to get a file descriptor for that file. Then you have to find out the size of the file by using, I think, fseek end, or maybe moving the cursor at the end of the file, and then you have to seek and see where the cursor is right now, which is the end of the file. And you also need, then you have to rewind and go back and move your cursor back at the start of the file, and you have to take difference of these two cursor positions and get the size of the file, and then read that much bits or bytes from the file and store them in a buffer whose size is also the same as that file, plus one, because you also would like to add null at the end, like stat struct and shared stat. I think, wait, stat struct was also in a language that, wait, I think, yes, stat struct I think was also in Zig. Yes, we did do Zig, by the way. Update yourself, and then just use mmap or freed. Okay. Shit, I remember reading file fopen. Shit, I remember reading file from in assembly, and that is what we had to do in assembly. Wait, I think stat struct. I used stat struct. Yep, stats. Get the stats. Defer is in Zig. Try getting the stats. And Zig is cool. Zig is cool. I would like to study Zig when it is complete, when Zig version 1 is out. Zig is cool. Right now it is changing too much. Huh, that is cool because of some overhead as compared to C. Yeah, I guess there would be overhead. Okay, we are getting file by file, and we know that, wait, we split, yeah, yo, we know that the size of these things is like this. Yeah, cool. Let's have a 2 by 2 grid vector of vectors that feels good. Or we will write a struct grid, and yeah, wait, is this, or am I being very stupid? No. There is a struct called grid, okay, and it will have, or maybe storing this just as a vector is also nice, or what? I think storing this as a vector is also nice, in which case vector vector of bool. shape, where each shape is a vector. Shit, nope. Each shape is going to be a two-dimensional vector, not a singular vector like this. So this is okay. Okay. Shape equals, so this thing is going to be a vector of shape, right? And here, okay. And I equals 0, and while this, okay. In one while loop, I want to read this much, so that when the while loop starts again, it starts from reading this new line. Wait, it is, I think, on version 1.14. Why not use pairs? If it is two-dimensional, each pair would store x and a vector of pairs. I think no, because so you are saying a vector of pairs where each pair would store the location of these points where there is something, and either that or coordinates of these points which do not have anything. But then if I'm going to store them in that manner, I mean, I'm not being, I've not decided on using the two-dimensional vector, this thing, as the thing that I'm going to move forward with, because I right now do not have any algorithm to solve this thing. But the problem with the one that you are suggesting, I think, is going to be the translation. Because if we are going to think in terms of coordinates, then then I think, like, yeah, there has to be a translation. There is going to be x and y coordinates relative to the start point of the whole region in which we are putting these shapes, and there are then going to be the coordinates of the shape that we are putting forward, and we would have to add offsets or things. And like, I think there is like no point in thinking about or arguing about the manner that we are storing these things just yet, because we actually do not have any algorithm. Okay, that is funny. Okay, right now I'm here and I do see the undo tree for this buffer right here. But to get to that buffer, I have to first go through this buffer, which has my file. And when I go to this buffer, here I will see the undo tree for this buffer, for this middle buffer, which has the coding part one. Is there a key or key press for undo and redo in Vim? What is Control R? Let's go Control R. I equals 0. I would be the index of the current shape that we are at. I don't know. I didn't read the question. I just heard that you wanted to store two-dimensional, not two-dimensional value, two-dimensional shape. But yeah, value. So just thought of suggesting in the input, it seems like there are three coordinates. Wait, these are not coordinates. This is a two-dimensional grid, and the size of that grid is 3 by 3, right? X-axis, 3 size, 3 by 3, and y-axis also 3. Okay. Right. If how to check string in C++, how to check if a string is a substring of another string. Find, yes, find, yes. Main string dot find this thing. If it is not equal to npos, then cool. If main string is find dot find, okay, no LSV support there. No member named find is crazy. Main string is a string, so what is the problem? Why don't we see find? Because its string is not even included. That is crazy. Still, no number named find. There is a member named find, but we need to also put given some other input. Okay, if there is no x in the current line, npos instead. Wait, shit. Okay, I'm stupid. On x. If there is no x, then we are at a file, and that is cool. We are at a position like this, right? And from that, I'm doing this because I want this to be general case, so that even if uh, these shapes were more than 5, then this algorithm would still work. Here I see that there are 5 shapes, so I could run this while loop 5 times manually. But yeah, I want this to be general, so that is cool. But what we can take as a given is that these shapes are going to be 4 by 4. So yeah, 4 by 4. Yep. So what we'll do now is string ss Stutztafel uh, for and I equals 0, I is small, not I, and yeah, we can use I. We can use I. We don't need this I. Yep. For int I equals 0, I smaller than 3, I plus plus, ss, uh, while ss, take the current location and vector here. If this is true, then we will initialize a new shape, shape, and yeah, current. Yes, current, and this thing checks out, but no, no, this thing does not check out. We here have to say vector bool. Now this should have checked out, but now it checks out. The internal and the external vectors both are initialized. Cool, that is cool, that is cool. Okay, and maybe no, maybe we should not initialize this internal vector. We should initialize this here. Yeah, vector of bool, let's call it row, and let's for and let's say j equals 0, j is smaller than 3j plus plus, or even let's say int shape dimension is 3 by 3, and here substitute 3 with shape diamond dimen. Ooh, shape dimension 3 by 3. Yep. If ss bracket j is a dot then row dot pushback seems like so good, or shit that uh dot pushback ss bracket j equals a hash. Yep. And yep, after making a row we will say current shape dot push back this row that we just created, right? And after this we will have the whole current shape 3 by 3. Yes, we will have the current shape. That is good. Yep. And we will add that shape to the shapes dot pushback current, and here file takes in assets to read this like new line at the end here. Yep. And that is cool. That is cool. Okay. And else, else if we are not here, if we are at one of these rows, then we have to, yeah, then we do have to parse this thing, which is actually very easy to do. Okay, let's, and this we are going to represent as a vector of numbers, as a vector of numbers. Yeah, normal vector of integers. Call them rows, does not matter. And yep, the first two entries in the row are going to be these two numbers, width and height. And but that, let's say, yeah, we will have a structure row where we have x, integer x, and y, which is wrong. Substitute dot with what, and row x and integer vector requirements. And yeah, row initialize one of these, and yo, yep, it is a grid. Hello, I am doing amazing. Hello, how are you doing? Yes, Sani. Yep, and we can like directly read the these two things. Wait, share. Since this is a string, we would like to convert this string into a stream, which would be much more beneficial? Or can we, because with a string stream, we can do this like X and then some random character and then Y with these two things, right? Or say current dot X and some char C random character. Okay. We'll go here and then here we can say current dot Y where X is not a valid operation because S is a string. So string stream is Toothstaffel. SS takes in S. So, and hopefully current X and current Y have these two values, this number and then this number. Then we have to skip a few more numbers, or we can make this thing a string. Making this thing a string. No, character makes more sense. After this, we have one more character, then one more character. Then, yes, then we will run a loop for, yeah, and integer, there is going to be an integer, let's call it I x or z, yes, z for int I equals 0, I is smaller than shapes dot size. However, shapes there are I plus plus, and for each shape ss takes in z and current dot rec dot pushback z. This like hopefully works. This hopefully works. And rows dot pushback row or no matching member function. Which does make sense. This should hopefully parse the whole input. Yep, let's print the shapes for int I equals 0, I smaller than n, I not n, I smaller than. Let's write a function that will take in a shape and will print the shape. Void print shapes take in shape s, and for int I equals 0, I smaller than s dot size I plus plus. And internally also for int j equals 0, j is smaller than s dot s bracket 0 dot size I j plus plus. That is crazy. And put char. Let's use, no, put char would not, would be fine, but it is not very wise to mix. Yeah, we can use put char. Put char is fine. Put char depending on what the current value is. S I j depending on the current value. If current value is on, then put char this. Otherwise, put a dot. Put char a new line, or we could have said 10, but they are the same thing. Print shapes, and here let's go for int I, or for shape s in shapes, print shapes takes in s. compile and run and error. Uh, and line, compile and run and nothing. So we are facing some errors. We are facing some difficulties. Okay. Some hydration. There should not be any problem in this. We are looking for x, which we will not find in the first place. Let's say print shape s or correct. Okay, we do see a shape, but we see a lot of shapes, which we should not see. And it turns out it's okay. This is the first shape that we do actually see. And is it the shape that actually really is there? And it is correct. Okay. And we are also reading, I think, the second shape correctly. Yes, we are also reading the second shape. Wait, no. Okay, we are reading the second shape correctly, but with the this is not how the third shape should look like. We are not reading these things in the third shape. The fourth shape is also kind of crazy. This is something that we are reading, and this is not even a shape anywhere. Wait, this is a shape. Okay, this is correct. This is correct. This is correct. The last shape is correct, but before that, there is a mess up. Why do we see this? Why don't we see this? Compile, and this is the first shape, and that is not, that is correct. I think we should avoid doing this. Okay, we are at least not seeing any error, which is good. Okay, now we are actually reading them correctly. Fifth shape also, and every shape. But why are we not going into the second else loop? After this, s dot find x. X is this x. Are we not reading? We are reading these. We are reading these. We are never going into this thing. Let's print the current string ss. Ss is the string. Yes. Is the string. This actually should have worked. Okay, SS. Why are we only reading these numbers? After 5, we got 42. Why just 42? Why are we not reading the whole? Shit, we are not reading the whole line because we are not reading the whole line. Okay. This thing is only going to read as much till we see a space because that is how things are read. So, okay, there's a line, get line, I think. Yeah, get line. And from this much, into this, get into S, size of one character is 1, and get line from a stream in C++. How do we read a line from a string? Well, I am not going to do it and now, maybe way later. Well, that's like completely fine. Also got a Twitch stream coming today. Hello. Just me playing with tanks and planes. World of Warcraft, or I think shit with I did saw that game which you were playing, Getline, standard Getline, and put a stream and get the line there. War Thunder. Yep. You are when you play War Thunder. Yes. War Thunder is cool. I have not played it, but a friend of mine was telling me that I think people were getting actual classified military data stuff to post on War Thunder blog or some place like that, and that is crazy. Crazy dedication. And put stream with a file and get it into X. And now we might be good to go, which we are not. Okay. Get nothing. Get this. Get nothing. Yep. We can remove this one, I think. Okay, why are we still going into this thing? Why are we not reading the whole line? Why are we not reading the whole line? Yep, first thing, the last line, and then two new spaces. Wait, but we didn't read one and two here. We read new lines instead, or empty lines, you could say. Yeah, that is correct. Yep. Bro, today is easiest. Wait, no, it does not seem to me very easy, just hard coded. There are there are only five shapes. Exactly, five shapes. What do you mean hard code? No, 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 I do not want to hard code this. No, no, no. I do not want to hard code this. That is like very easy hard coding this. I want to parse this. Okay, take an SS. Something is wrong, something is wrong. SS is being printed correctly, but S is not getting filled. Shit, that would make sense. Yes, I think we do have to do a extra line here. This one, and now we might be happy, and we are not happy. Yes, there are, yep, and the input parsing, like first, yep, they are. So parse. Wait, no, no, I am making this general in a way so that if there are more shapes ever in the future, which is not going to be, I will read them separately. Like I can also parse them. That is what I want to make. Hmm, 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 hmm. This is not going so well. Something is actually off here. Why am I not reading this? Why is S like empty? Here, before this line, S is only being filled here. Yes, S is only being filled here. So what is the problem? What is the problem? And why is there a macro rhyme? Yes, 0 hash 0 colon is cool, and SS is the last line. That is also cool. Standard getLine file dot s. Still, this so we got this shape instead of this. We started reading from the next line, which is not very good. And the last line SS we got was this. Okay, now we go. Now it is cool. Now this is cool. Okay, and I think this makes sense. Okay, here I'm using get line on the file input stream to get input into the s string variable. And so okay, we start reading from this line, right? And we are calling get line on s for the file stream file, and we read this whole line, and our cursor ends up at this location. Then we are not using the getLine operator, we are using this thing which reads till the next line, and I think our cursor ends up at the end of the line. And then when we use this thing again, this ignores the new line and reads from the next character. So here is a new line. This operator, read operator, ignores this new line and starts reading from here, and the cursor I think will end up here at the end of the second line, and then again at the end of this second line. Then I have to do get line twice, first to exit this line and get here, and then again to exit this line and start afresh for the next while loop from this line. Okay, or we could actually not do this, and here instead of using this we could here also use getLine, and I think that would also work. Read from file into ss meaning Stufen Staffel, or something like that, some Hitler thing. Compile and let's go. That is nice, we do end up at the right place at the right time. Okay, why general won't work? Because you will have to go one line forward to check if the next line has grid data. If the wait, I'm seeing here if the current line does not have a x, then it is index for for a for a pattern. That is what I'm seeing. And yes, if I ever see that the current line has a x, I will treat that line as grid data and parse it in this else loop, kind of like that. And they won't have given you a delimiter if they wanted it to be general. Shit, I wrote like instead of line. The next line has grid data. Yeah, I mean, it is up to them if they want to be general. I want to be general, and I'm seeing that the pattern here to be general is checking for this. That is like, yeah, and it works here in this condition. And now I think we are reading the data correctly. That is cool. Let's also write a print grid function that will print the grid data. Print grid, and this thing takes in a row R, and yeah, actually see out or printf I think would be better. %d, this thing into %d, a new line, comma r dot x, r dot y dot, and yep, and then shape. What we can actually do is dot purely, and yes, so this is overload on this like left shift operator or put into operator, which we can use now with standard output and print a vector like this. R dot rec is a vector of integers. We can just print this with this, and there is no problem. And I think we should also flush before we do this. And yeah, that should print a row. And yep, let's print all the shape for auto s in not in shapes. And Print shape taken it for auto row R in rows, print grid and pass in row. And yep, we are parsing everything correctly. That is cool. That is cool. Are we parsing everything correctly though? 47 into 46. Let's check the last one. 47 into 46, 46 and 57. 46, 57. Cool. That is just part one. And now the actual difficult thing of how to solve this. How to solve this? How to solve this? There are five shapes which you want to put together and make them take up this much space. Can we brute force this thing? 3 by 3. No, brute force would be like too bad. No. Brute force is too much. Brute force in the way that I'm thinking about would be too much. Yep. We have shapes, 3 by 3 shapes, 3 by 3 normal pattern shapes which you want, and a bunch of them, like a lot of them, and we want to put them in a grid, in a two-dimensional grid which has a certain height and a certain width. How? These shapes, you want to put them on a 2 by 2 grid, shapes on a grid, and I have never solved a question like this, a problem like this. Shapes on a grid, shapes on a grid, shapes on a grid. And share this. I think for this one there might not be any other valid configuration for putting all of these shapes together other than this one that we are seeing right now, because look at this, they are showing one pattern by one character, so all the C's represent one character which looks like an H. C is representing an H character, H pattern, and I this is like very close fit. There is no spare room to wiggle this whole shape around. This goes from one end to other end, both in height and in width. So this is a very close fit. and every placement of every single pattern is very specific to reach this end, but we don't want to figure out whether or which way to put these shapes together. What we want to know is, can we put them together? Can we put them together? Can we put these shapes together? Is there something that changes if we have too much space? Here, if you look at this shape, then this cell is never going to be occupied. Whenever we are putting this 5 pattern here, this cell is never going to be occupied because there is no other shape which will fit in this pattern number 5 in such a way to take up this cell. But does that help? I'm thinking of maybe we can see how many of, like, whenever I put certain 5 pattern number 5 on the grid, then how many cells this is going to take and how many available cells there are, and the total number of cells, all of these shapes when present on the grid this many times, they are going to take, like, if is this size of the grid enough to allow that much space, right? For example, here we can count up all the places or the number of squares, that cells that these shapes are taking, but no, that would not, yeah, that will not help us, because maybe we might have a single row of cells remaining which has a lot of continuous cells. And here also I think we have 1 2 3 4 4 and 9, which is 4 plus 9 4 plus 5 9, which would in theory let us fit another pattern which is going to take 9 cells, but actually we cannot fit any more shapes into this thing, so no, that is not going to work. But that is at least the minimum requirement. If the wall total area that is going to be taken by these shapes is greater than the total area that is given to us, then of course we cannot fit all of these shapes into this grid, but that is not a definitive answer. And yes, like for example, if we have a grid that is 1 by 90, right? The area of that grid is going to be 90, and in theory, like according to this bad logic, we should be able to put at least 10 shapes into this 90 volume area space grid, because each shape takes at max 9 cells, so we should be able to stack them side by side, 10 of them, but we cannot because this thing does not allow them to be put in that manner. 1 by 90. Yep, so this is different, this is different, this is different. And this is certainly Not the easiest in the last 5 days. This is certainly not, well, not for me. If we reduce the whole problem to something simpler, experimentation. We have a two-dimensional grid and we want to put space, put things onto that thing. Why does this sound like there was a Veritasium video on something about on something like this, similar to this, about Roger Penrose tiling or something like that. This is the question for the day. Someone is wondering. And I'm even thinking about how would we even solve this simple 4 by 4 problem when we want to put the two of these patterns together. We can even put, yes, we can even put two of these patterns into a 4 by 4 grid, but we cannot put two, wait, we cannot put two of these patterns onto a 4 by 4 grid, and we certainly cannot put two of these. We cannot put two of these. We cannot put two of these patterns. Wait, we can actually put two of these patterns in a 4 by 4 grid if we do something like this. Yep, the shape is like this, right? Yep, and the other one can just fit right in here. Yes, it is not here, like this. We can put two of these. Can we put, I think we cannot put two of this shape into a 4 by 4 grid. And yes, I don't think, yeah, we can ever put two of these shapes. No, 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 we cannot. And we cannot put two of these shapes onto a 4 by 4 grid. Yep, we cannot. Okay. We have patterns, and yes, we have patterns which we want to put together onto a grid, onto a grid, onto a 2 by 2 grid. Thinking, I'm thinking. And backtracking, might be an option, but no, there seem to be too many possibilities for a backtracking solution. Yep. Yes, I think there are going to be too many possibilities, and I cannot even imagine what part two of this question is going to be like. Part two is going to be crazy. Christmas tree farm. Shit, we cannot even put two of these shapes together. This shape together. No, nope. We cannot put two of this shape together also. Yep. In a 4 by 4 grid. There just seem to be so many possibilities. We can think of it like, let's say, if it is possible to put these given shapes, these given patterns onto a 2 by 2 grid of this size. Let's say there might be one solution for it, or multiple solutions, or there might be no solutions for it to be possible. So let's say there are one or multiple solutions. We will assume that it is true that there is at least one or more solutions, and if they exist, are they, like, we can double down on them and we can find them. If there is one or multiple, does not matter, we will choose one of them and we will find it. And if there are no possibilities, then we won't be able to find the solutions. I'm just thinking. There are solutions, yes, but we do not want to find if there are what they are. We just want to find if there is any solution to this or not. If it is possible to put these patterns onto this grid, and that might mean uh, if there is a solution, then the solution might have some property, and if that property is true, then we do have a solution, or if it is false, then we do not. Then what would the property be? What would the property be? This is geometry. This is 12 into 5. 12 into 5. Okay, let's before moving into 12 into 5, let's look at this again. 4 into 4. This is a 4 into 4, and this is how, this is one way we can put these together. Okay, I'm just thinking. How can we? We can put these together in a 4 or 4 grid. And yes, like I probably won't be able to do this problem here on this stream right now. But the thing is, I won't use AI because I do not want to use AI for Advent of Code. That is just too bad of working ethics, I think. Using AI for Advent of Code is too bad. Nope. And it is okay if I'm like unable to do this, and not if I think I won't be able to do this right now. Probably. Maybe I'm just thinking about this in completely the wrong dimension. I'm thinking about this in terms of shapes, pictures, and geometry. Putting shapes together. Maybe there might be some other way that I have to think about this problem. Bit mask, but bit mask in 2 dimensions would be crazy. Wait. Okay, let's actually think about this in terms of brute force. I cannot think of a calculated dynamic programming kind of approach where we use knowledge about what where we want to get and use that in our favor. Okay, if we look at these dimensions, right, let's see what the maximum value of these dimensions is, right? Yeah, max x and max y. Let's say both of them are equal to 0. Yep, both of these are equal to 0, and mx equals maximum of mx comma r dot x, and my is maximum of my comma r dot y. Yep, so we have maximum of these two values. We have x space my, compile 50-50. Okay, 50-50, and these shapes are the maximum size, let's say, of a grid is 50 by 50, 50 by 50, 50 by 50, and these shapes are 3 by 3. And if we say that like top left corner is the cell where we are putting a shape, then there are going to be 50 minus 2 and 50 minus 2, 48 by 48 different possibilities for this, which is, let's just say 50 by 50. 2500, that is like 10 cube for one shape. And let's see what is the maximum number of shapes. Maximum number of shape in a row. Mx shapes equals maximum of mx shapes, comma, accumulate s dot s. What is s? Shape is a, wait, that does not, this thing does not even make sense. Mx shapes equals maximum of mx shape, comma, accumulate r dot rec onto vector of type integer. Accumulate, no matching function called to accumulate. It's starting and ending, my bad. Dot begin and r dot rec dot end. And here between shape, max number of shapes is mx shapes. 386, which is, this is into 4, because there are 4 different possibilities for each shape, and the total time complexity would be around 10 power 6 for each of the shape, for each of the grid or row, you could say. And in total there are rows dot size number of rows. There are thousand rows, which is not good, which is not good, because if we do use brute force, then in the best case, kind of, brute force is going to take 10 power 6 time for one single case, and there are 1000 cases, there are 1000 rows, like this, there are 1000 records, and each record is going to take about 10 power 6 executions, 10 power 6 time complexity, and 1000, that would be 10 power 9 in total, and that is like 10 second, 1 second or 10 second. Even though it might work, we will have to wait for a little bit. There will be fixes we will have to do while implementing this brute force approach, but that is not the right thing to do. That does not feel like the right thing to do. There must be some better algorithm, better than 10 power 9 algorithm to solve this, which is better than brute force. Yep, which is better than brute force. Which is better than brute force? Okay, I'm getting call, but right now, better than brute force. Better than brute force. Better than brute force. Yeah, I guess I will take a walk and think about this calmly. Better than brute force. Better than brute force. Yeah. And yes, certainly, I do not want to use ChatGPT for the advent of code. Some way to solve this, which is better than brute force and you. And yes, I will guess I will have to end the stream also. Like I have to take the call. And apart from that, yeah, I will think about this. How to solve this. A solution which is better than brute force. And even if we were to apply use brute force here, how would we go about implementing the brute force? I think the time complexity that I calculated offhand is wrong. 10 power 9. I think this is the time complexity. Actual time complexity is going to be worse than this. Okay, let's go over this. There are at max, let's say, there are for each shape, there are 2500 possibilities where we could put that shape in. And let's say into 4 because there are 4 different orientations for each shape, like this one, and this one. 4 different orientations for each shape. So in total, there are, let's say, 10,000 possibilities for each shape, and at maximum, there are, as you saw, around 300 some shapes. There are maximum number of shapes in any record is 386. So that is like 3, 8, 6, and 1, 2, 3, 4. Each shape, and whenever we do have, and this is not very like actually correct, the actual time complexity would actually be better than this. This is 10 power 6, 6 decimal places. Yeah, 10. This is 10 power 6, and I think brute force is good. Wait, yes, I think brute force is going to be good because when we have some shapes on our 2 by 2 grid, then a lot of no, 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 no. Nope, I am not calculating this thing correctly. I'm not calculating this thing correctly. Wait. Shit. Okay, what we do know that this number is the correct number for how many different configurations our system could be in, and most of them are going to be false. And by false, I mean there might be like there will be a lot of configurations in which there is a 9 by 9 grid, and all of the patterns are in here, like literally at this location, and that is not correct. That is not going to be correct. That is not going to be a correct shape. So what we can do is we will try to go through all of these different possibilities, and we can see at the point that we see shit, we messed up, we cannot move forward in this direction because there is no place to put a new shape. No, Now we have to arrive at a brute force calculating manner in which the order of putting shapes does not matter, in which case we will put everything together in a on the grid and the order would not matter. We will put everything. Oh, I will have to think about this. Yes, I will have to think about this. How to even implement the brute force. Uh, because I think this number is correct for how many possibilities there could be for putting around 386 shapes on a grid that is 50 by 50. Yep, I think this number is correct for that. Yep. And after generating each possible possibility, we will go through the whole grid and see is this valid or not. And if it is valid, then at least we have one valid grid and we will say, look at this, we are cool. Yeah, I will have to think about this. Yes. Yes, I think, but this number is correct for how many possibilities there are. We can generate all the different possibilities. We can generate all the different possibilities and go through all the different possible configuration and go through each one of them and quickly is a complicated word, I think. Quickly and see if the current configuration is correct or not. And that is what I'm thinking. And yeah, I'll have to think. Yep, that will also be the end of the stream. I have to take a like phone call. Hey, is there no part? There is a part two. I just haven't even done part one. Yep. There is always a part two. Mhm. Yep, that would be the end of today's stream. Unfortunately, I yeah, I was unable to do today's question just now. Yep, and that would be the end of today's stream. But I will not use ChatGPT or any AI to do this, and I will do this. Yep, don't worry. And bye.